요 리더를
What?
Ignore Chen. It's a butter time.
All right, so the answer, what's the answer to part A?
8.33.
How'd you get 8.33?
Chen, this requires no work for A.
It requires no work for that.
Yeah. Please read the problem
Shit, you're
Too
falling.
busy interfering with other people's questions that you can read
You're
the
falling.
question.
And you have to.
Really, like it's
Should
literally in the
drop your
first.
pencil.
It's literally in the
Check,
first
check,
4
check.
words. A body falls freely.
Falling. So
Pick
like-
up your pen and drop it.
Okay,
Yeah,
like-
yeah, pick up your pen and draw.
Dude,
That's
like
a
it's
good one.
falling, so like, what's pulling it? Gravity, so what's the, like, what is that?
Come on, Chen, you're gonna fail this class if you don't know this.
We probably should write a diagram of a body just falls.
That's not what it is.
Okay, so the acceleration due to gravity is 9.81 meters per second. The second thing they want us to find is the distance.
You're thinking too hard.
Why are you thinking about it way too hard?
This isn't class, this is physics one, intro.
This is intro, right?
Exactly.
Aerodynamics, bro. Crazy.
Yeah, but that should be the speed for every single like gravity. Anything that falls from like.
Anything that falls on Earth will always be 9.81 meters per second. All right. So to find the distance at 3 seconds, so now we have a new variable, which is t equals 3. We're going to use s equals v naught t plus 1/2 at squared. We're going to plug in all our values, so we have 0 meters per second for velocity times 3 seconds. This goes to 0 plus 1/2. Can anyone tell me if acceleration is positive or negative in our situation? Why?
Because like, it's not decreasing it, it's not like slowing down, it's like always the same.
No. Remember at maybe 2 weeks ago, I explained to you guys whatever the direction of the initial movement is considered the positive. So since we're starting from rest at some high distance and then falling, our initial direction is downward. So in this case, acceleration will be positive. But if we, jumped up, so your initial movement was upward first and then went downward, then your acceleration will be negative.
Gotcha.
Okay, where was I? Acceleration, 9.81 meters per second squared times, what was it, 3 seconds? Can somebody tell me what they got there?
For final velocity or is this?
This is distance after 3 seconds.
88.29.
88?
I calculated it wrong.
There we go, it's 44.15
Yeah,
to be
I calculated
exact.
it wrong. Yeah. Oh, yep, I see what I did wrong.
How'd you get,
No, I forgot the half.
you forgot the half, okay.
Yeah.
All right, so that's the answer to B. C is asking, what is its speed after falling 70 meters? I'm just gonna try to box these off. I used to have a professor in college when he would teach. He would have this really funny pose. He would like crab walk across and do this when he would do it. It was hilarious. We all loved it. All right, C. So we are finding VF at 70 meters. Okay. So our S equals 70 meters. Let me just throw that in like this, make it easier for you guys to understand. S equals 70 meters. That's what we're looking for. What formula would you guys use for this one?
What was it? VF squared equals VI squared.
There we go. Yes. VF squared equals V initial squared. Sorry?
No, he's asking why you would use that formula.
Because we have our acceleration and we have the distance traveled. So you have to look at the variables that you already have out of our list of four or five equations. And each one, you can have like a different arrangement of 3, 4, 2 different variables and still figure out the third one. In this one we have, what was it, plus AS? That's squared. Yes. There you go. Better. Two AS. All right, so then you simply plug it in. So we have our initial velocity was 0. VF squared equals 0 meters per second squared goes to 0 plus 2 times acceleration and times, what was the time? No, sorry, distance, 70 meters. All right, that makes much more sense. I was getting confused looking at this. Can somebody tell me what they got for that? 37? Through 37. Okay.
No, it's the, without the square.
Without the square root, okay.
37.06.
All right, what did you get it for before you guys square rooted it? What's 37 squared?
Like before, I got 1.37 times 10 to the third.
So if I can do
Yeah.
that.
All right. Yeah, we're just
1,373.
gonna square root it here, so we don't have to do it there.
You square root it.
VF equals, what was it, 37?
Yeah.
The final answer is 37.06, I think, right?
0.06 meters per second. There we go.
Yeah.
Let me check mine. Yeah. All right, cool. I got 0.4, not 0.6. All right, so that's part C. Part D, we are looking for the time required to reach a final velocity of 25 meters per second. So we're looking for D equals time at VF equals 25 meters per second. Any idea which formula we should use for this one? D. Which one's D?
Final velocity equals initial velocity plus acceleration times time.
You are correct. All right, so our final velocity will be 25 meters per second. This is asking until we fall from rest, 0 meters per second, plus 9.81 meters per second squared, times t. So t will equal 25 meters per second over 9.81 meters per second squared. Which I got 2.55 seconds. Something funny, Shan? All right, and then the last section, what is the time taken to fall 300 meters? So now we are given E time at S equals 300 meters. Thanks. Which formula are we going to use for this one? Yep. So we will plug in 300 for S equals 0 meters per second times T plus 1/2 9.81 meters per second squared. Squared. This goes to 0. That would be 600. What was it? 9.81 squared. Squared, square root of that, minus 2, T equals .82 seconds. There we go. Does that make sense to everybody? Any questions? Yeah, so I just took this 2 and just multiplied. It doesn't matter, you could have divided this by 2 and then divided that by. Yeah. I mean, it just depends on how you want to do your algebra. Did you get 7.82? Okay.